Imagine standing on the moon. It's a vast, quiet, and empty place. The ground beneath your feet is just gray dust. But what if I told you that dust is not just useless dirt? Chinese scientists have just announced something incredible in July of 2025. They have found a way to take that very same moon dust, the stuff we call lunar soil, and turn it into things we need to live. They can make breathable air and even fuel for rockets. This is a huge discovery. It's like finding gold, but instead of a precious metal, it's something far more valuable for an astronaut. A way to survive and explore far from our home planet, Earth. This breakthrough changes how we think about the moon. For a long time, we saw it as a dead world. We thought we would have to bring everything with us from Earth to survive there. Food, water, air, and fuel for our return trip would all need to be packed on a rocket. This is very expensive and very heavy. Every single kilogram we launch into space costs thousands of dollars. But this new technology offers a different future. It tells us that the resources we need might already be waiting for us right there on the lunar surface, mixed into the soil. Think about what this really means for future astronauts. Instead of packing a giant tank of oxygen, they could pack a machine that makes oxygen for them. Instead of carrying all their rocket fuel for the trip home, they could create it on the moon. This is the ultimate form of living off the land. It's a fundamental shift in our strategy for space exploration. Scientists have tested this new method with real lunar soil. The samples brought back by China's Chang'e 5 mission in 2020 were used in the lab, and the process worked. It's no longer just a theory, it's a proven concept. This discovery feels like something out of a science fiction movie, but it is very real. The team of scientists, led by Lu Wang, has published their amazing results for the whole world to see. They have given us a new recipe, a set of instructions for how to use the moon itself to support human life. It's an exciting first step on a long journey. We are learning to use the resources of space to explore space. This single idea could unlock the door to permanent bases on the moon and even missions to other planets like Mars. The gray dust is not just dust anymore, it's a promise of a new era. So how does this amazing technology actually work? It might sound complicated, but the basic idea is quite simple and very clever. The system uses something the moon has a lot of: sunlight. Scientists designed a process that captures the sun's powerful rays to create heat. This is called a photothermal strategy. It's like using a giant magnifying glass to focus sunlight onto the lunar soil. This intense heat is the first step. It bakes the soil and forces out any tiny bits of water that are trapped inside the moon rocks and dust. Getting water is a huge victory on its own. Once they have water, the next step begins. The system also uses the carbon dioxide that astronauts breathe out. We exhale CO2 with every breath. On a spaceship or a moon base, we have to remove it from the air anyway. But with this new tech, that waste product becomes a valuable resource. The water that was extracted from the soil and the carbon dioxide from the astronauts are put together. The sunlight-powered system then uses a special process called photothermal catalysis to transform them. A mineral in the moon dust called ilmenite helps this reaction happen more efficiently. The chemical reaction breaks the water, H2O, and carbon dioxide, Colorado, 2 molecules apart. It then rearranges them into new things. The main products are hydrogen gas and carbon monoxide. These might not sound useful at first, but they are key ingredients. Hydrogen is a powerful rocket fuel. It can be used to power landers taking off from the moon or even rockets heading deeper into space. The system can also use these products to create methane, another excellent fuel. And most importantly for human survival, the process can be adjusted to produce pure, breathable oxygen. The best part about this entire system is that it is designed to be self-sufficient. It runs almost entirely on sunlight and local materials. You don't need to ship complex chemicals or giant batteries from Earth. The moon provides the soil, the sunlight provides the energy, and the astronauts provide the carbon dioxide. It is an elegant loop, a small-scale ecosystem that turns waste into life-sustaining supplies. It's a smart and sustainable way to build a home away from home, using the very ground you are standing on as your factory. The importance of this technology for the future of space exploration is enormous. Every trip to space is a battle against weight. The heavier a rocket is, the more fuel it needs to escape Earth's gravity. This is why astronauts pack so carefully. If we can make our oxygen and fuel on the moon, we don't have to launch them from Earth. This is called in situ resource utilization, or ISRU, and it is a game changer. It means our rockets can be lighter, or they can carry more science equipment and habitat modules instead of just supplies. This makes missions cheaper and more effective. Having a local supply of fuel and oxygen also makes a moon base much more sustainable. Imagine a permanent human settlement on the moon. Without this technology, that base would constantly need resupply missions from Earth. It would be like a remote Arctic outpost that needs planes to fly in every single thing it needs to survive. But if the base can produce its own air and power, it becomes much more independent. It can support more people for longer periods. This is the key to moving from short visits to actually living and working on the moon for years at a time. This technology doesn't just help us on the moon, it turns the moon into a gas station for the rest of the solar system. The moon has much weaker gravity than Earth. That means it takes a lot less energy to launch a rocket from the moon than from our home planet. If we can refuel our spaceships on the moon, it becomes the perfect starting point for longer journeys. A mission to Mars could stop at the moon to top up its fuel tanks before heading into deep space. This would make the trip faster and allow the spaceship to carry more scientific instruments or crew. Ultimately, this breakthrough is about opening up space for more people and more ambitious missions. When the cost and complexity of space travel go down, the possibilities go up. We can think bigger. We can plan for permanent research stations, lunar industries, and maybe even tourism one day. By learning to live off the lunar land, we are taking a critical step toward becoming a true multi-planetary species. This Chinese technology isn't just a clever science experiment. It is a foundational piece of the puzzle for humanity's future in the cosmos. It helps make our dreams of space a practical reality. While this new technology is incredibly promising, we are not ready to build a moon base just yet. Scientists still have some very big challenges to solve before astronauts can rely on it. One of the main problems is that lunar soil is not the same everywhere on the moon. The soil from one crater might have different minerals and a different composition than the soil from a lunar mountain. The success of this process depends on minerals like ilmenite. If astronauts set up a base in a location with very little ilmenite, the system might not work very well, or it might not work at all. We need to map the moon's resources much better first. Another hurdle is that the process is not perfect yet. The scientists who developed the technology admit that its current performance is not yet high enough to fully support a human crew. It can produce oxygen and fuel, but not fast enough, or in large enough quantities for a real mission right now. They need to make the chemical reactions more efficient. Also, the system relies on carbon dioxide exhaled by astronauts, but there might not be enough of it to produce all the water, fuel, and oxygen a base would need. They will need to improve the technology to make more with less. We also cannot forget about the moon's brutal environment. Any machine we send there has to survive extreme conditions. On the moon, temperatures can swing from boiling hot during the day to freezing cold at night. There is almost no atmosphere to protect against this. The surface is also constantly bombarded with dangerous radiation from the sun. Plus, the whole system has to work in a vacuum and in low gravity. Building equipment that is tough and reliable enough to operate for years in these conditions is a major engineering challenge that will cost a lot of money and time to solve. So, while we celebrate this amazing scientific step forward, we must also be realistic. This is a marathon, not a sprint. The journey from a successful lab test on Earth to a fully working factory on the moon is long and difficult. Scientists and engineers will need to overcome the problems of soil variability, improve the system's efficiency, and design hardware that can withstand the harsh lunar world. This discovery has lit the way, but a lot of hard work remains. It is a fantastic start, but just the beginning of our quest to truly live on the moon.